Okay, welcome back to the trig videos. We're going to use the trig ratios now to find side lengths on triangles. In this triangle we have an angle of 32 degrees, that's our specified angle. We have another side that is 20 kilometers long, and that side is the hypotenuse. And the side that we're after, x, is next to the angle, so it's the adjacent. If there's going to be any confusion here, it's between the adjacent and the hypotenuse. Remember, the hypotenuse is the longest side and it's opposite the right angle. The adjacent is the other side that's next to the angle. So if we've got an angle and we've got an adjacent and we've got a hypotenuse, the trig ratio that we need to use is cos. So if we just write out the ratio, cos theta is equal to adjacent over hypotenuse. And we put in what we know for the situation. So cos 32 degrees is equal to x is the adjacent and the hypotenuse is 20. So we need to rearrange that now because we want x on its own. X is being divided by 20 on the right hand side, and the opposite to that is timesing by 20. So we'll do that on both sides, which means that we're left with x on the right hand side and 20 times cos 32, which I don't really need to write the times. We need to evaluate this. You can just do 20 cos 32 or 20 times cos 32 equals on your calculator. You'll come up with the answer 16.96 for x. Now, just a couple of little housekeeping things about calculators. Make sure that your calculator is set in degrees. If you're using the Casio, it's very easy. Sorry, let me say that again. With the Casio, you set it once and it will virtually stay there, but you do need to find out how to set it. With the Sharp calculator, it is very easy to knock the DRG key and to change that setting. So if you try this for yourself and you're not getting 16.96, you need to check that. The other thing we need to check for is the reasonableness of the answer. The hypotenuse was 20, this side must be shorter. We haven't put units in, so our answer is 16.96 kilometres. Okay, we'll go on to the next question. In the next question, we're finding the unknown length b, and this is a slightly harder problem because b in this one is the hypotenuse, and when you've got an unknown hypotenuse, when you substitute in, you've got an unknown in the denominator, and that's always a little bit trickier. But let's keep going. And the 1.24 side is the opposite. It is opposite the specified angle of 19.1 degrees. So we've already discovered that that's the sine ratio, so we write out that sine theta is equal to opposite over hypotenuse. And so sine 19.1 degrees is equal to, the opposite is 1.24, and the hypotenuse is b. Now, to rearrange this, we need to get b out of the denominator and into a numerator. So what we're going to do is multiply both sides by b. So that means b times sine 19.1 degrees is equal to 1.24. Okay, because when you times both sides by b, it reappears on the appears on the left hand side and cancels out on the right hand side. Now to get b on its own, we need to get rid of the sine 19.1, so it's going to be 1.24 divided by sine 19.1 degrees. We can do that on our calculator. It's 1.24 divided by sine of 19.1 degrees, and that comes out at 3.79, and the units are metres. just checking that the hypotenuse is the longest side. Is this the longest side of those that are known? Yes, it is. So that seems to be a reasonable answer. If you want to be methodical about what you're doing, first step is work out what sides you've got and then find the ratio that goes with that. Put the values in. The next step is rearrange. The next step is calculate. There's usually, a setup where you end up multiplying or you end up dividing depending on what you're doing. But learning that is not good. The third question's a problem-solving one. A person standing 5 metres from the base of a tree. The angle of elevation at the person's eye level to the top of the tree is 37 degrees. Assuming eye level is 1.5 metres above the ground, what is the height of the tree? So we'll have our tree and we have our person, and we'll have to assume that the ground is horizontal. So we'll draw a horizontal at eye level. And we said the person was 5 metres from the base of the tree, so that's 5 metres there as well. And the angle of elevation to the top of the tree, that's this angle here, is 37 degrees. And we want the height of the tree. Well, we know that the height for this part of the tree is 1.5 metres. So let's just find this part and add it to 1.5. So just looking at this, we have a right angled triangle. It's a bit messy, and this side here is the opposite and this side here is the adjacent. So we're talking about a tan ratio. So tan theta is equal to opposite over adjacent. So tan 37 degrees is equal to h over 5. So to make h the subject, h is being divided by 5. What's the opposite of that? It's multiplying by 5. So multiply both sides by 5. You're left with h on the right hand side and you get 5 times tan 37 on the left. So that turns out to be 3.77 metres. So the overall height of the tree is 3.77 metres plus the 1.5 being the eye level of the observer. So that all comes out at 5.27 metres.